So is that the worksheet you do that the structure?
Yeah, but we won't have time through enough. You know, unfortunately, you're going to miss where we get into like the more difficult data structures. You guys got your names on, right?
Yeah. I tried to, wait. No, I didn't. It's just an electron dot notation showing.
Okay. Start with a couple things. Covalent bonds. So what we're going to do for this next probably 3-4 days is specifically focus on covalent bonding. That's how I would. I realize running electronegativity a bunch of times can get long. You could also put, yes, they have similar electronegativities, but they also need to have high electronegativities. Because metallically bonded things have similar electronegativities too, but they have low electronegativity values. So maybe you should say atoms with similar high electronegativities. Okay, so we've already kind of addressed this as we have talked about the 3 types of bonding, but we're going to specifically focus on covalent here. So I want to hammer on it even more. Okay? We've already said that what happens with the electrons when you covalently bond something. What's going on with the electrons?
They're sharing.
They're sharing. Okay? So what happens is a covalent bond is forming, or a chemical bond is forming, when a pair of electrons are shared. Now, it doesn't mean a pair each are shared. What it means is one electron from each of the atoms are shared to form one pair. Does that make sense? Okay, if Mari is an element and I'm an element, if I share one and he shares one, we have a pair that is being shared. Okay, so a total of 2. So when we're doing covalent bonds, each bond represents how many electrons then? Do you think? 2. If I have 2 bonds, I have 4. If I have 3 bonds, I have 6 shared electrons. Okay? And that would be 3 from each then if you were to do a triple bond, which we'll get to that as we progress.
Right.
Okay? This allows them to have a full octet, okay, and forms their covalent bond. Fluid structures.
Correct.
Who has a PTAB?
You didn't. You didn't.
Like what, right in front of you?
Mari. Ugh.
How long do you spend editing these videos?
I don't edit them. That's the thing. So your face is gonna be all over all these videos. Is it on? Did I turn it on? Sit your buns down. Seriously, sit down. Okay, we can't waste any more time. Cool? I'm talking to your parents today. Just letting you know that.
Okay.
Right.
Threaten the parent.
I'll make sure that they heard about today. All right. A method of showing the covalent bonds and arrangement of a molecule using electron dot notation. So we're going to start off with something very simple. Okay. Hydrogen has one valence electron. We're going to show it bonded with, let's say, chlorine. Now, are these two nonmetals? Why do they have to be two nonmetals? Because it's covalent. Okay? So what I have here is chlorine has 7 valence electrons and needs 8 to be stable. Hydrogen has 1 valence electron but needs how many to be stable? They only need 1 more because they're stable with how many? 2. It's an exception, right? Okay? So, what I can do is, remember I said sharing occurs. Okay? And I said, when I went with Mari, right, didn't I give an electron, he gave an electron, and so that created a pair, right? So if hydrogen shares an electron and chlorine shares an electron, we create a bond. And a bond we represent with a dash. Now, what does a bond represent from an electron standpoint? Okay, but how many? 2. Okay, so we're saying that that dash, or that bond, represents 2 shared electrons, 1 from each. Alright, so if I were to look then at chlorine, assuming these 2 electrons are held by hydrogen and chlorine. So how many electrons do I have around that chlorine, assuming it has the 2 shared electrons? 8. 2, 4, 6, 8. And how many does hydrogen have? 2, which it needs 2 to be stable. Okay? I haven't given you any process of how we're going to do this. As we progress, we're going to get into kind of what's going on here. Okay, go ahead and put this in. I mean, it's kind of common sense, but just in case, that those electrons that we form a bond with are going to be spending the majority of their time right in between the nuclei's. I'm kidding, gross.
That's no.
Do it.
That'd be bad.
That's no hurt.
That won't hurt. Yeah. Hope that wasn't on camera.
It probably was.
Oh,
And they saw that you were threatening
it's not threatening children.
children.
I was not. No, I was just showing her the trap.
In her ear?
No, I didn't put it in her ear. I put it near her ear.
You're admitting on the camera.
No. I could be walking by with a mouse trap like this, and it's getting near your ear. That doesn't mean I'm trying to get your ear.
That's not the same.
But you weren't walking by with it in your
Okay,
ear.
here we go. So what this is saying again is that these electrons are being shared. They're being shared in between the nuclei of the atoms, and yeah, that's funny.
Yeah.
Yeah, this is called, these 2 electrons that are shared have a name. They're called bonding pairs. Did I give you guys the vocab sheet?
I think so.
I'm pretty sure that's on the vocab sheet, right?
Yes.
No?
Set rule, electronegativity.
No, it's not.
There it is.
So the bonding side, okay, kind of the same thing.
There aren't very many vocab words.
No, it's a lot more application. So we're gonna spend like 3 days doing a little structures.
You should do 4.
11, that'd be 2 extra parentheses.
Yeah. Okay? That's just saying that those 2 electrons that we're sharing have a name. They're called a bonding pair. Pair meaning 2. Bonding means they bond. Makes sense? Get it, Steven? Alright, this is just, you don't have to write this in, this is just going to show what's really happening. Their orbitals are overlapping. Now do you see how each of them have their full octet?
Yeah.
Okay? They have their full octet because these two electrons are on both of their outer rings or their orbitals. Now I know technically this is not exactly what it looks like, but it does a good enough job explaining the whole process here. Okay? This is important. Bonding sites. Bad memory. Okay, this probably seems simple, but understanding this idea of bonding sites is going to help you tremendously when doing Lewis structures. Okay? So here's how you can identify bonding sites. Okay? The number of bonding sites is essentially how many unpaired electrons you have. How many unpaired electrons are up here?
4.
4. That means I have 4 bonding sites. What if I had 3 unpaired electrons? 3 bonding sites. 2 unpaired electrons. What if I had no unpaired electrons?
Ain't no bond inside.
There's no bonding sites. Is somebody that has an octet, are they going to bond?
No.
No, they're already stable. Which group has an octet?
8.
Noble gases. A group 18 or group 8A. Think about how you look at it. Alright? So, if this has 4 electrons, could it share those 4 to have 4 more for a total of 8?
Yes.
Okay. So this guy's going to have 4 bonds around it. We will talk about that might mean 4 single bonds, that could mean 2 double bonds, that could mean 1 triple bond and a single bond, that could mean 1 double bond and 2 single bonds. But in the end, it's got to have 4 bonds around it if it wants to be stable. No other way around it. Okay? Oops. What they're trying to show here is that the group 15 or group 5A, everything has 5 valence electrons, so everything's going to look like this, and it's going to have how many bonding sites?
3.
3. Okay? You're never going to break up, at least not at this level, a lone pair. These are called lone pairs. The ones that aren't involved in bonding are called lone pairs. I'm not sure if that'll come up in your notes or not, but okay? The ones that are going to be involved in bonding are going to be the ones that do not have a pair with it. Okay? Because they have to share to get the pair. You know what I mean?
Yes.
Okay? Are you seeing the trend here?
Yes.
Oxygen, and everyone in oxygen's group has 6 valence electrons. So how many bonds would be around oxygen or anybody in group 16? 2. Could be 1 double bond, could be 2 single bonds. We'll talk about double, single, and triple bonds as we progress. Okay? No way around it. Anything in the halogen group or group 17 only can have how many bonds?
No.
1. No way around it. Only going to have 1. At least at this level. To exceptions as you get to higher level. Okay? Alright, why do atoms bond, Stephen?
Because they bond to have 8 outer
I think scientists still don't know. Okay? True or false? Covalent bonds occur between atoms with similar electronegativities. Similar and high. You should say that probably too, right? Because metallic bonds also have similar electronegativities. You know, right there, Moira? Real comfy. Okay, Moira, covalent bonds occur when two atoms what? Okay. Let's talk about, we're almost getting into the Lewis structures. Okay? Let's get into this. I know we've already talked about diatomic elements. We're going to talk about the difference between a diatomic element and a diatomic molecule. Okay, so it says a diatomic molecule is a molecule containing just two atoms. That's all it says. Does it say anything about having to be a specific element or anything like that? It just says two atoms. Okay? Diatomic element is specifically two atoms of the same element. Okay, so I just put a list of these guys up here. I want you to be able to tell me, is a diatomic element, is a diatomic molecule? Could you call it both or neither? Who wants to take the first stab at this one?
CO2.
Anybody? Moira?
Sure.
What do you think?
I don't think it's
It's neither. Why is it neither?
either. Because it has
Okay, so it's not a diatomic element because I have different what? Elements. And it's not a diatomic molecule because it contains more than two atoms. Okay? Shane? That's what I would think. But I know that I can say, yes, it is a diatomic element, but doesn't it also fall under the category of a diatomic molecule as well? Because doesn't this have two atoms? Doesn't say anything about, as long as it's got two atoms, it's a diatomic molecule, so technically this is both. So let me give you a hint. You can never have this only, because this is always that. Right? There's no diatomic molecule that wouldn't be also a diatomic molecule.
But you said the same.
Yeah, he says it's a diatomic molecule.
Sorry. There's no such thing as a diatomic element that isn't a diatomic molecule. If you're a diatomic element, you have to be a diatomic molecule. Does that mean diatomic molecules are always diatomic elements?
No.
No. Okay? Next one. Stevie.
That's every single one except for the break.
Why is it only a diatomic molecule?
Because it's made of different elements.
Okay? Cannot be a diatomic element because it's not the
Same.
Not the same element. Okay? Does it have two atoms?
Yes.
Bonded together?
Yes.
Diatomic molecule. Mari? How much time we got? Please tell me more than that. Okay, quickly. This one.
HF. Oh, that's.
Yeah, well, this is diatomic molecule.
What in the world?
I think you're
It's
on.
messing with you.
What'd you say?
I ain't saying nothing.
Diatomic molecule. Two atoms, not the same. How about this one? Both. Two atoms, yes, but they're also the same. So they're both. How about this one? Diatomic molecule. Not the same, but still two atoms. How about this one? Both. Two of the same, diatomic element, also two atoms. And this one? Neither. Because it's not the same element and it's not two atoms. How many atoms are there? Three atoms. Okay? Does that help? Stevie, getting it? Oh yeah. Okay. Remember the 7-on-7 rule? You could have just looked up at the 7-on-7 rule and told me if that was diatomic or not. I know I have made you write in the 7-on-7 rule and the diatomic molecule or diatomic element thing so many times you're probably getting sick of it. But it's so important for as we progress and start doing chemical equations, you need to know this. So I just, through constant repetition, I'm hoping by the time we get to that, you'll have this down. And I would write somewhere next to this seven-on-7 rule. So you should really say diatomic elements too. I will use them interchangeably when I'm dealing with these guys. Then we're going to do Lewis structures to end this. You might need me to refresh the 7-on-7 rule. Anybody? Starts with the atomic number 7. Makes the shape of a 7. There are 7 of them, and hydrogen. 1, 2, 3, 4, 5, 6, 7, and hydrogen. They don't have astatine in there. You can cancel that one out. We don't ever use it, so. Okay? So, just know that whenever these guys are alone, they will always be in diatomic form. You will never see H by itself, naturally. Okay? If you're going to see a lone H, it'll be bonded to itself, H2, and so forth. Okay? Last thing. We're going to start simple with diatomic Lewis structures. I'm going to show you, or abbreviate, or explain the difference between a double, a single, and a triple bond. We'll start with the easy ones, just do the diatomic guys.
Should we write this down?
Yeah. And we'll do, let's see, what's not in your homework? We'll do Cl2. We'll do O2. And we'll do N2. Okay, ready? Okay. We'll start easy, we'll work our way up. Eventually we're going to get to more complicated Lewis structures, but we're going to start easy. Lewis structures, the very first thing you're going to do with the Lewis structures is you're going to write the dot notations. Okay? Chlorine, how many electrons does it have? Okay, now notice what I'm going to do here. Notice how I put my two bonding sites towards each other. Why would I do that? That's where they're going to bond. And remember, we said covalent bonding is when electrons what? Share. Okay? We're not going to share our lone pairs here. We are going to share our unpaired guys. Okay? Now remember, when you share, one from each, correct? So I'm going to take one from that chlorine, and replace it with a what?
A dash.
Representing a covalent bond. A single covalent bond. That bond represents how many electrons? 2. Okay? Pretty simple. Do they both have 8 now? If you assume that that bond is both. Okay? Let me finish. Oxygen. 6, right?
Yeah.
Now it's a little trickier here because I can only put one of the bonding sites towards each other. That make sense? Okay, I'm gonna go a little bit over here, but you guys will be okay. Notice, how many bonding sites do I have? 2, which means that I'm going to have to bond twice. 2 here, 2 here. So I'm just going to form the single bond first, 1 and 1. Now here's what a lot of people like to do. They like to take these 2 electrons, which are going to form the double bond, they like to go like this. Don't do that. Okay? Don't do that. Here's how you do it. They're shared in between the nuclei. Remember, I have 2 bonds here, which means how many? I have 2 pairs, which means how many electrons? 4. So I would say 2, 4, 6, 8 around oxygen. Stable?
Yeah.
2, 4, 6, 8.
Stable.
Stable. Are you seeing the trend here?
Yes.
Nitrogen. Notice how I put the lone pair away from everything. 3 bonding sites each, forming a what? Triple bond. Okay? 3 bonding sites, 3 bonds. 1. And remember, I'm not going to put a line above and below. I'm going to remove 1 from each when I form the second, remove 1 from each when I form the third. Make sense? 1 here, 1 here, there's my double. 1 here, 1 here, there's my triple. Now, 3 bonds, how many electrons? 6. So 2, 4, 6, 8. 2, 4, 6, 8. Are all of them octet stable?
Yes.
Yes. Do I have a class next hour? No. Okay. Test?
No, I just need a pass.
To take the test?
Yeah.
Okay.
See, look what I have. Oh, no.
Does that hurt?
Yeah, it's fine. Share the phone call.
Yeah. These are only
All right.
Just do
Where did we go? Did you not get that?
Because I
You're
don't
just
like
doing something
What's this, Steven? Trash? What are you doing with the trash?
this. We're good.
Ready? Test?
Do I need anything besides that? What's this, Steven?
Like, no, but like when I'm
You always carry all your lunch in a tortilla.
I'm gonna
go to like your activity.
guess that's how the English feel.
Oh, it's not lunch, dang it. I always try.
Oh look, I see a free pencil.
My friend and
It's a band name, right? Fire it.